So hi everyone, let's start the session. So let me share the whiteboard first. Yeah, are you able to see the whiteboard? Veer Singh, Karan and Manjot, are you able to see the whiteboard?
Yes.
So oh yeah, great. So the topic for today is graph, DFS and BFS, right? So these topics are related to graph, and I already covered the basic concepts of graph and tree. So like I will try to explain this DFS and BFS through this tree and graph perspective so that you can understand it easily, and then we will solve some problems like where we can apply DFS and BFS, and how you can think that okay, this problem can be solved through DFS or BFS. Okay, so most of the problem where we can solve the problem through DFS, we can also solve the same problem through BFS. But sometime if we are talking about graph, so in terms of traversal and all, we can use any one of them, but it depends on the requirement. Sometimes DFS is better and sometimes BFS is better. So let me explain like DFS and BFS first. So DFS means depth first search and BFS means breadth first search. So let's say if I have a graph like this or any structure, this is a tree. When we are creating like this is a tree. When we can do like this, then it become a graph, right? Or let's say this. So let's say if I am here and I want to move at any node, or if I want to go through the all nodes, then I can either go through this DFS or BFS. So if I want to traverse all the node of graph, so I can choose anyone. Like DFS means I will start from here. I will select one node and I go there. Then again, I will select another node. It may be this or this. We have two options. So let's say I am selecting this one, right? Then again, I can either select this one or this one or this one. We cannot select this one because we are coming back. So I can again select any one of one node. Let's say I'm selecting this one. Okay, then I can here I can select this one, but this is already visited because I was there in the starting phase. So either I can go here only. So I will go here, and after that I can select this one, but because I already visited this, so I will not select this. So this is the depth first as I reach to the depth. So I traverse this one, this one, this one, this one, this one, and I reach to the depth of this graph. I cannot go.
Are you sharing the screen?
Yeah, no, actually I am sharing the whiteboard. So
can you share the link, please?
Okay, I think the link is in just a second.
It would be easy, like if you share from the screen and at one place rather than juggle between the things. Actually,
I think now you will be able to see it. Are you able to see it?
Not now yet.
Not yet.
Not yet.
Okay, very good. Participant can view. Open and okay. Did you get any notification? Okay, just a second. Let me share the link itself. So I will get the link from whiteboard and actually I'm not getting a link. Most of you are able to see it, right? I can see like Veer Singh, Kareen, Sam, and Manjot are able to see this. But why you are not able to see it? Okay, just a second. Share with viewer.
Let me disconnect and connect again.
No need to. I'm sharing in the chat itself. Yeah. Can you click on this link
Yeah, sure.
and let me know if you are able to see? So this, are you able to see it?
Yeah, it's loading actually.
Okay. So. Okay.
Yeah, you can continue. So it's saying request access actually.
Now everyone is able to see this, right? I cannot see. Suresh, are you able to see it or not?
No, it's asked me to request access actually.
Every time only you are not able to see this. I don't know why. Because everyone is able to see. Okay, let me close this and let me share it again. Just a second. This one, open collaboration and share. Our viewer. Okay. Only invite user. Okay. Interview.io. That is only. Sign is to be given. Okay. Given. Well, okay. I'm sharing a new whiteboard so that you can. Now, can you see this whiteboard? I think most of you are able to see the whiteboard, right? Suresh, are you able to see it or still you are not able to see? Okay, Suresh is not there. He dropped off. Oh, new one. Okay, fine. In that case, you are able to see the old one, right? Or let's start with this new one itself. No issue. We can start from here, and when Suresh come back, I will share the screen so that he can see this screen as well. Okay, fine. Then let's start. So I was talking about this DFS and BFS, right? Depth first search, brief first search. So basically, I'm talking about this example, something like this. Let's say I can draw anything like this and this. Okay, or like this. Okay, so when I'm going through this and then this, and let's say this one, and through this and then this. Okay, so I'm choosing this, and I come here. Now I cannot move anywhere. So I will select a path, and I keep on moving until I reach out to the end. So this is the end. I cannot move anyone from here. I cannot move to any node. So that is the one path, and this is the that's why it is a depth first search, because I am going to the depth and then I'm taking another path. Now I will come back here and check. I can go either here and here, but I don't have any option. So I can come back here, and from here I can go there. Like so, from here I can go there, and that is also a last path. Like end of this path. So we can say this is there is like we need to perform this DFS 2 times for this graph. One path would be this, and another path would be from this. So both this DFS are the graph algorithm DFS and BFS. And in DFS, as you can see, we are going through one by one and we are coming back. So it will use stack data structure. Okay. So whenever we are using DFS, we are using stack, and VFS. Let me explain the VFS with the same example. Then we can move to the problem solving. On this, and then this and this. So BFS means breadth first search. So I will go here and then I will go here. That means after one path. Then again I will go here and here, and from here I will go here and I will go here, but this is already visited. Similarly, from here I will go there, and from here I should go there, but it is already visited. So this is the BFS. That means breadth first search. So from here I can access these two nodes. So I'm directly moving here, and then from here I can access these three, and then I can access this one. So this is also known as level order traversal. Like I am going at the single level, then second level, and third level, and fourth level. But here we are like I'm going to first level, then second level, then third level, then again second level, then third level. So this is not a like level order traversal, but this is a level order traversal. So I think and here for DFS we are using queue. Okay, so this is the main difference between DFS and BFS. When we are using DFS, we are using stack data structure. When we are using this BFS, we are using queue data structure. Any doubt till here? Okay, I think Suresh, are you able to see the screen, or I should share the screen?
I can able to see the screen now.
Okay, fine, great. So is it clear to like this DFS and BFS?
Yeah, clear.
Okay. So Suresh, as you were there in the session of graph and tree, so if I ask a question, so would you like to explain the answer? If you can, otherwise I will explain the answer. So I also give the same question in for your homework as well, like this snake and ladder game, or I can say chess game, right?
Yeah.
So let's say let's start with a simple game. Okay, so here we have these things like this. Okay, like this. We have some number 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Let's say 11, 12, 13, 14, 16, 17, 18, 19, 20, and 21. Okay, and I have a dice. Okay, I have a dice with 4 faces. So generally dice has 6 faces, but for this, let's say we have only 4 faces. And you are rolling the dice, and let's say if you are getting 3, so you are directly jumping here. Okay. Now let's say if 2 players are playing and they are just focus about this number, we don't have any we can put the condition. Let's say at number 12 we have some condition that or we can say we have a snake. So if you are at 12, you can directly move to 1. We can add those condition and later, but let's say we have the simple one. So we have a dice, or we can say a random function which can generate a number one by one, or we can say we have 2 arrays like this. Okay, like this. Okay, let's say 1 2 1 3 2 1 and 1 3 8 not 8 4 3 4 4 like this. So let's say this is a player A and this is a player B. Now let's say if this player someone is throwing this dice, so this is the occurrence of first player, this is the occurrence of second player. So let's say player A get in the first attempt getting 1, so player A is here, right? And player B is also getting 1, player B also here. Okay, now we have these operations. So can you tell me at the end of this operation, who will be the winner? So the winner would be who is having the maximum value. So let's say here both are at the starting level, and then he get 2, so it will move 1 and 2. So A will come here and B get 3, so B come here, right? And so on. So can you tell me who how we can run this program, Suresh?
So we can move step by step, and for each person, And as we keep on moving, we can keep adding, and we have to see what's the maximum value in the kind of like, and so now here it is 20, it should be 20 basically. So
Okay.
whoever is getting equal to 20.
Okay. Great. Now because we have this given array, right? We have this given array already, so we don't need to worry about this dice, right?
Yeah, exactly.
Okay, so this is the simple question that we can at every point of time we can check that, okay, what is the number, and we can directly jump to that. But let's say if we don't have this and we have this dice with me, and at the when I throwing a dice, I can get any random number, right?
That's correct.
So in that case, what I should say, I should like select for number 1, 2, 3, 4. Any number I will get, right? So I have to go with these 4 possibilities, right? So in first attempt, I can either get this one, I get 2, I can get 3, I can get 4. So in place of these A and B, let's assume that at every point we have 4 possibilities, right?
That's correct.
So we can go with that, and we can do this problem through BFS, breadth first serve. So every time, let's say if I am getting 1, so I can maintain the queue here. If I get 2, I can maintain a queue here. When I can get 3, so I can maintain the queue here. And when I get 4, I can maintain a queue here. Again, I will get 4 possibilities here, right? Similarly, 4 possibilities here. Because this function is randomly generated, like throwing a dice. We cannot know that, we cannot say that, okay, next time we will get 3 or 2, right? We can get any number. So this will be done through like this BFS, where we can maintain a queue and we can directly jump on that. And after that, we can put these, what should I say, snack and ladders here, so that we can complete the game, right?
Yeah.
So okay, so
Harikam, I have one question. Why do we require QE here? Basically, we can do only BFS, right? Basically, we can maintain the stack, and we can keep proceeding to the next step, right? Basically.
No. Like for example, I am here, right?
Yeah.
So I can either get 1, 2, 3, 4. I may have 4 possibilities, right?
That's correct. Yes.
Yeah. So I cannot say that you should follow the one path. I am saying that okay. So when we are developing a program, so we should know all the possibilities, right? So let's say if we are getting 1, then what are the possibilities? So if we are doing DFS, then we should go till the end for this path. Then we can come back for this second possibility, right?
Yeah.
But if we are using this BFS, so we can go, like follow all these step one by one. Like from here, I can go either here, or here. Like, right?
I mean, like when see, there is no concept of snake and ladder here. Like we need not do that, right? Because once a person throw the dice, like he can't able to take it back, right? He will continue to move forward only. In that case, like there is no point of again checking all the 1, 2, 3, 4 possibilities, right? Basically, because suppose he got 4, and he will add that, and next time he got 1.
Let's say he will get 4, so he will come here, and after that,
simple, right?
Yeah. So in that case, that's what I'm saying, that here we can directly go through that. But when we put more conditions here,
exactly, right? Yeah, that I totally agree. When we get the snake and ladder stuff, basically we'll go back to the point where we had to go, and then again we have to keep starting.
Yeah, definitely. So okay, so I already asked you to solve this problem during the graph session, right?
Yeah,
so have you solved any these kind of problems?
No. Actually, since 2 weeks, kind of I was totally.
Okay, no issue. So let's start with the because like you attended that graph session, so you are much aware of this DFS and BFS, but others are not that much aware. So let's start with the simple example. Then we will solve a graph question. Okay. So let me start with a basic tree. So here, and then we can directly go for the traversal. Right now, let's say 1, 2, 3, 4, 5, 6, 7. And as you already solved this problem, so I expect that you should explain the answer. So let's say I want a result like this: 1, 2, 3, 4, 5, 6, 7, like this. So this first level, second level, third level. And I also explain this DFS and BFS, so anyone can explain that how we can get this result.
Yeah. But
so can you explain what should be the algorithm and what should be the data structure for finding this?
so we have to use the queue here, and so first we take the root node.
And, okay, Q would be the data structure, fine. And what would what should be the algorithm? Like, do we using any popular algorithm like?
Yeah, we use the breadth first search only here, basically because we have to do the level of the traversal. So use the
so whenever we are using this BFS, so automatically for implementing BFS, we need a queue, right?
Exactly, that's correct.
And when we are using DFS, we need a stack, but we don't need to use that stack, because we are going to use that backtracking or recursion that is already implemented through the stack.
Exactly. So it's a kind of inbuilt as a part of recursion, basically.
Yeah. So basically, when we are using backtracking, so backtracking or recursion, that is itself use stack for function calling.
That's correct.
Okay. So here we are using queue. Great. So any one of you, if you are not getting the point, please let me know. Then we will solve a graph problem. So I'm just covering the basic concept. So here, let's say I am using this queue. Okay, what would be the operations? And I also need these in a new line. Okay. Okay, great. Tell me what should be the procedure?
So then I have to take the first one, and then.
Okay, I got this first one. I put it into the output result, and then what I will do, I will put this into the queue. Okay, fine. Now,
so again, we have to maintain a list of lists, basically.
Sorry.
We have to maintain the list of lists every time.
Okay, fine. Okay, forget about the programming concept. Just explain how you are using this. So let's say we have a list. Okay, so in the first list, I have added one.
I was at 1, and that's the only one element I have in that, and I will add it. And whenever I will add that. Before that, I will go for the left and right, and I will add all of the elements.
Okay, so you are saying I should add 2 and 3, right?
Exactly, yeah.
2 and 3. Okay, great. Now.
So now the queue size is 2, and now I have to go back to the first element.
Okay, so you are popping out this, and then you are adding
exactly,
this 2.
Yeah. So now queue size is 2, and again we'll pull the 2, and
okay, so I am popping out this 2, and where I am keeping
the
this
4 and 5, basically, because
so where should I keep this 2?
We can pop it off, actually. We can print it and we can pop it.
Okay, so I am printing it. So how I can get, okay, let's say I am printing 2 here, and I am putting 4 and 5. Okay, right?
That's right. Yes.
Okay, now I am getting 3, and I am printing this 3, and I am getting this 6 and 7. Right?
That's correct. So now that level is completed, and now
so how do you know that the level is completed? That is the problem. Like that is fine. I can get the answer like this: 1, 2, 3, 4, 5, 6, 7, 8, 6, 7, like this. But I'm not getting that. Okay, this is the first level, this is the second level, and this is the
that's what I mentioned. Like we have to maintain the list of list. And
okay, so okay, fine. Let's say I'm maintaining a list of list. Let's start from the starting. I have this 1, and then I'm removing this 1 and adding 2.
Whenever I'm removing that, I put that 1 into the list, actually.
Okay, so I put this list. Okay, fine. Then I am removing this 2. So where should I put this 2? Let's say list of list is a 2D array, right?
So whenever you are pulling it off, you can whenever you're starting a new iteration, when you start with the 2 and 3, right? At the time you create a list, and whenever you're pulling it off.
Okay. The problem is remains same. How do I know from this queue that, okay, this is the ending of this level. Like after 1, how do I know? Like for 1, I can understand.
That's where like we have to see the size actually, right? So every time we see the size, and when it is reaching the size, you are done with it actually.
So how do we know that, for example, here I have the size 1, here I have size 2, here I have size 4, and so on. Here I have size, let's say 8, here I have size 1. How do I know that, okay, which level has how many elements?
Yeah. So we are maintaining the queue, right, Shalikram? Actually,
We are maintaining this.
I'm based on the queue size. I will do the operations basically, right?
Okay, so the queue size is like we are using a single queue, right? Where I am putting all the elements. Okay, let's start. I think you are missing the concept. So here, let's say I put this one. Okay.
Yes.
And we have this list of list. Okay. Fine. Now, just tell me. After this one, what I will do? I will remove this one, right?
Yeah. Once you are removing it and you create a list actually.
I create a list and I put that one into that list. Fine.
Yeah, you put that one into the list, and now you traverse the left tree. Okay. And if you have any element.
So I put these 2 and 3 into the queue. Fine. Now.
Exactly.
Now I remove this 2, right?
See, right, at the starting, the I can say it's like yeah, somewhere we maintain the queue size, and based on the queue size only we iterate it actually.
Okay, so we cannot maintain the queue size. For example, like I can understand what you want to explain, that when we have 1, we know that the size of this level is 1. When we are removing this, we have size 2 and 3. So we know that the size is 2. But when we are removing this 2, we are getting 4 and 5, right? Now we cannot say that the next level would be the size of 3.
Yeah, I got your point actually. So,
yeah. So here you are doing good, but you are missing. I explained the same question during the tree session, that what should we need to think about here, how we can differentiate the level. So just tell me, like from where we are ending the level, after this, and after this, right?
Yeah, that's correct.
So whenever we are getting this 1, 3, and 7, we should do something, right?
Yeah, that's correct. So
okay. Now as we cannot differentiate these things in the queue, so when we are adding this data, we should do something so that we can understand. We should also take some identifiers, right?
So now I got an idea, Shalikram. Actually, right, when we are maintaining the list of lists, right? So what I do is, when I started with 1.
Okay. First of all, we don't need a list of lists until and unless we are returning the answer as a list of list. Okay. So we can directly print the data without using list of list. But let me explain, then let me know if you have any doubt. Or okay. So whenever we are getting this first element, first element, right? This one. Okay. We know that in the single first level we have only one element, right?
That's correct.
So when we are putting this, we should put some identifier, like, so we are putting, let's say, null. Fine. Any doubt till here?
Yeah, no doubt.
I'll explain why we are using this null. But for now, just think that we are putting this null. Okay. Why? Because we know that this is the last element of this level, right?
Yes.
Because like on the top level we have only single element. So when we are putting this, so now eventually we will remove this one, right, and print this one, or we can put it into the answer, and we can simply go with left and right. So we can put 2 and 3. Any problem?
No.
Okay. So when we are getting,
I have a question. I don't think we need the identifier. I think we can just always get a length of the queue at every level and just iterate through that length. Then, so we don't even need the identifier. We can just get the length at every level. Then just iterate through that length only. Then use that length.
Okay, so here the problem with length is, let's say, if we are here, we are putting 1. So we know that the length is 1, right?
Yes, so we get a length of the queue at that specific place.
So
then
you are
iterate
saying
through
that
the
the
length.
length. Okay, so here you are saying the length should be 1. Here you are saying length should be 2. Here you are saying length should be 4, right?
Yes.
But that is not true. For example, here we have only one element, but according to this assumption, we should have the length of 8, but we have only 1. How do
No,
we?
so the length will be 1 because the length will be 1.
How?
Because so when you get to the level 1, 2, 3, right? So then in that place we iterate through length of 4, right? Then
Yeah,
from there we get 8.
Okay, so but when we are at 4, we don't know that whether 5 have any child or not.
Yes, we don't know, but
yeah,
since we don't know, right, we'll go through the length of 4. So we check for 4 that, okay, does it have a left and right child? It has a child, which is 1. So by the end, we finish that iteration, that level 4, in where the level is 4, we only have one element in the queue left, which is going to be 8. Then we just iterate through that one length of 1 and just print it.
Okay, so actually the problem is we are going through the level order traversal. So after 4, we should jump to 5. We should not jump to 8, right?
No, so 8 will be at the end of the queue. 8 will be after 7.
Yeah, so like we have this queue 1, then we are removing this 1, we are pushing this 2 and 3, right?
Yes, so then we'll go through the length of 2, right?
Yeah, okay.
Then we'll put 4, 5.
Okay. And now I'm removing
3.
this 2. I'm removing this 2, okay?
Yes, then we'll put 4.
I am putting this 4 and 5, right?
Yes, so then we'll pick 3 because we are going through level length of 2,
now,
right?
now I am removing this 3, right?
Yes.
And I am getting this 6 and 7. But
6
here,
and 7, yes.
Yeah, here I'm like ending this level. But how do I know that this is the ending of this level?
Yes, so we know because we are only iterating through the length of 2.
At the adding after 2 and 3, when we are starting it, we maintain the size actually. So
then we go through that level 4.
Yeah. Every time we store the size whenever we are going to the traversal. Okay. So that one size is completed, 2, 3, and whatever the list is added.
Okay. Suresh, just tell me how you are calculating that size.
So at the end of this, at the beginning of the iteration, in that while loop itself, we just get, okay, this, the size is going to be q.length. If it's Java like q.length, then that will be 1. Okay. For the first level.
Okay.
Then we
so
check it back on the right child.
Okay, fine, great. So here you are saying the length should be 1, right?
Yes, length is 1. Now, then we iterate through 1.
Okay, now we have this queue and we are putting this 1 and the length is 1. Okay, fine.
Yes.
Now, just when we are removing this 1, right?
Then we'll iterate through level size of 1, right? Which is only that one only.
Level is done.
Put this
level is done. We have put this 1 here. Then we put this 2 left child and right child. Okay.
Yes.
Now you are saying at this point of time, I should find calculate the length, right?
So we get a length. It's going to be 2.
Okay, length is 2. Great.
Yes.
Now
then we iterate through a size of 2.
So I have length of 2, right?
Yes.
Now what should I do? I should remove this 2.
So you iterate through length of 2, right? So for that 2 is going to be the left and the right child, which is 4 and 5.
So I am removing this. Okay. Till here, just after this, I should remove this 2, right?
Yes. So we iterate through size of 2, right?
Okay.
Then we'll remove the first one, which is 2.
Okay. So I will put this 4 and 5.
And
right?
5 at the end. Yes. Then it remains one more iteration.
Okay. So one more. Okay. So how do we know that we should do one more iteration through this length?
Yes, because the length is 2, right? So we iterate through length of 2.
Okay, great. So here I know that the length is 2. Okay. So after this, I can come here. Okay. And I can put this 6 and 7, right?
Yes, 6 and 7. Then we remove 3.
Okay.
Then
great.
The length is 4 now.
Okay, great. And then I can again calculate the length, right?
Yes, that'll be 4.
Length is 4 now. So now I need to run a loop 4 times, right?
Yes, 4 times. Yes.
Okay. So I am removing this 4. I am removing and putting this 8. I am removing this 5, and I'm not doing
no children, so we don't do anything.
Yeah. I am removing 6. I'm removing this 7. Okay, great. And then I again calculate the length. Length is 1, right?
1, yes. Then we just
And
do
then
it for that one.
I am taking this, right?
Yes.
So just tell me, we are using we are running this. We are using this queue, and inside this queue we are using this while loop, right?
Yes, that's correct. That's good.
Okay. So if we are going with this option, then we don't need a loop. Okay, so just let me complete this one, then we can compare both of them. Okay, so both of them, the complexity is like same, but the code quality is not good. Like here we are using some bad indentation. I'll explain after completing this explanation. Okay.
Yeah, sure.
So like we can get the result from here as well, but here we need to take care of this length every time. We need to calculate this length, which is not necessary, right? So
yeah,
this can
I think it is I think because even putting none, right? Because putting none at the back is too like
okay.
Because
So here we are only putting null after this every label. So the like these null should be log of n, right? Only log of n, because every label I am putting this null, right? Similarly, whenever we are putting this null, that many times we also need to find this length, right? Like whenever I am putting this null, similarly here we are calculating this length. Like after 1 I am putting this null, so here we are getting this length after 1. Similarly, I am putting null here, so I am again getting length after this. Similarly, I am putting null here, so I am getting length after this. So eventually I am doing the same operations, right? But here I am not using
null is
any
a more efficient approach. That I agree, because we need not do the calculation every time. Go for the size and do the
and we don't need any loop, right?
Exactly. Yeah.
So okay, so okay, here what let me complete this and then we can like compare both of them. So when we are getting this one, right, I am putting some identifier, so not null, let's say x, anything which through which we can identify, right? Then I am removing this 1 and putting this 2 and 3, right? And whenever I am getting this null or this x, I am just moving this x after this, simply adding this x, right? I'm removing this, and when I am getting this x, so I am simply putting this null here, x or null here, right? And after that I am removing this 4, 2, and I am putting 4 and 5. So 4 and 5, right? And again I'm getting this 3, so I'm removing this 3 and I'm putting this 6 and 7, 6 and 7. And when I'm getting null, that means this order, this label is done. So first label is this, second label is these two, and then again this null, so I simply put this null here, right? Any doubt?
Yeah,
then
no
I
doubt.
put this 4, I put this 8, I like remove this 5, I do nothing, I remove this thing, do nothing, remove 7. So this level is completed. I can simply say that okay, we should jump to the new line, or we are getting null, so we again put this null here, right? And when I remove this 8, so I'll know that okay, after that 8 we are null, we have null, so that means we should what should I say, we should send this null here, right? And when we are getting this 2 null, that means this is the end of this list, right? Oh, sorry, queue, right? So both approach are looks same, and the time complexity would be same. But here we are also running a while loop inside this queue operations, right?
Yeah, we are doing additional computations.
Yeah, so that overall time complexity would be same, because eventually we are removing this inside this while loop as well, but the code quality is not good, because we are running a loop inside loop, even though they are performing same number of operations, but we can do this without that in a loop, right?
So Shalikam, can you code this actually? So this approach, I just want to see like how it is.
Okay, fine. So So let's say online Java compiler. So should I write the sudo code or actual code?
If it is actual code, that would be great. So
okay, so let me open that. What was the label order travels, right?
yeah, lead code 102 problem number.
Traversal lead code. Label order traversal. Okay, this is for premium only. I think I cannot. Okay, I can add it, right? Yeah. Okay. So okay, fine. So we have tree, and that the structure of tree is this, right?
Are you sharing different screen?
Oh, okay, sorry, my screen is not visible. Just a second.
We see only board actually.
Okay, just a second. Let me share my screen. Can you see it?
Yeah, now it is.
Okay, so this is the lead code problem, right? So eventually I cannot run it because this is for premium, but I'll explain the code, right?
Yeah, sure. That would be great.
So here, let me create a queue first of all. So let's say queue of because we need a tree node, queue of type tree node. Okay. Let's say queue equals to new. I think for queue we can add dq. The structure is new linked list. New linked list is also a queue, or we can say array dq. Array dq. Okay, let me check the right thing. How to define queue in Java. So for defining queue, okay, like this, a linked list. Okay, this is a new linked list. That's what I okay, like this and this, right? So we have this queue, and what I can do, I can directly queue dot put or post this root, right, in the starting. Any issue? Suresh, are you there?
Yeah. Do we have a push operation here?
Okay, so I push the root because I don't need to do anything with the root, right? I can directly put this root. Any issue with this?
No. I mean, like it's a queue structure. So I mean to say it's a add. That's what I was saying. So
No. We have this push and pop in the queue, or we can say add as well.
Yeah.
Okay, fine. So we can do this queue dot add. That's a null. Okay. I think we should use a small null. Fine. No, any issue?
No.
Now while queue is not empty, is empty. We have this function, right? So we can say not empty, right?
Yeah.
Now what I can do, I can use tree node temp equals to q dot top, right? Or we can say q dot remove. We can also go with the q dot remove, right?
You want to see the queue top node basically?
Yeah.
So then q dot peak, I guess.
Yeah. Okay. So top is for stack if we have peak, right?
Yeah.
Or we can go with remove as well. So what I will do, or we can simply say remove, because when we are removing, we are getting that element and we are deleting from this queue, right?
Yeah.
So if this temp dot node temp double equals to null, what I will do, I will put this temp this q dot post sorry, not post, add null, right? An issue with this?
No.
And here also I'll check if q dot peak double equals to null. That means I put this null and I am still getting null. That means there are only nulls, right?
Then we can exit, right?
Then we can exit or we can break, right?
Yeah.
Any issue with this?
No.
So this is the end condition. We are not getting this, but we okay. Otherwise, what we need to do? We need to simply go with this root. Sorry, answer or whatever we want. Answer. Let's say we have the let's say we are having, or we can simply system.out.println, right?
Yeah, that's it.
System.out.println, and we are printing this temp dot data. Any issue with this?
So we want to return as a list of list, right?
Yeah, we can print this data, and when we are getting this null, we can simply say new line, right?
Yeah.
After this, we can say new line, right? Any issue with this?
No.
Whenever we are getting this null, we can simply move to the new line. Otherwise, we will simply print the data with the separated value, right? Or here we can use double vector or 2D array, and we can put that data here, right? Or we can say list of list, whatever you want, right?
Yeah.
Now, after printing the data, that means removing from the queue, what I should do? I should put this if temp dot left is not equals to null, right? Then I should add q dot add this temp dot left. Remember, I am putting this tree node, so I can get that like left and right from this tree node itself. I don't need to worry about the tree, right?
Yeah.
So I will do this, and similarly for the right, if temp dot right is not equal to null, then only I can get this. What should I say? Q dot add temp dot right? An issue?
No.
That's it. Because it will automatically terminate after this, right? So we don't need to terminate, and we are printing it, so we should not return anything, right?
Yeah.
So any doubt here? Then I'll explain the other code as well. Okay. An issue with this?
No.
If you have any question at any point of any line of this code, then you can ask so I can explain that line. Right here we are not doing any complex operations, right?
Yeah.
Okay, now let's come to the that size one. Okay, so let me remove this thing, and let me here what I am going to do. After this, I am calculating the size. So let's say size equals to what should I say? Q dot size, right?
That we had inside the while loop actually. So
no. For the first element, we should get it after here itself, right?
Yeah.
After this, let's say when we are removing this, right? While Q is not empty, so here what should I do? I should okay. So I am removing this, and I am decreasing the value. So let's say size minus, right? Size minus. Okay. So no, I have to think about this. I should not do this, right? This loop I should not do. Size. Now I should run this loop while okay. Q is not empty. What is empty t. Okay, that should be the thing. And here I should run while. Okay, here I should find size equals to q dot size, right?
That's
Okay,
correct.
here. Okay, so I don't need this. Great. Now I need to run this again while, or I can run a for loop, right? Anything. For
Yeah.
integer I equals to 0, I is less than n, size I plus plus. And here what I am doing, I am doing this q dot remove. So I can simply print system dot out dot print, and I am printing this q dot remove, right? Dot data, not val, right? Well, right?
Yes, that's correct.
And let's say after space. Okay, and after this for loop, okay, and I also need to put, okay, so what should I do? Tree node temp equals to, I should copy this and paste it here, and remove could be like this, and I can simply say temp here, right?
Yes.
And after this, what should I do? I should add q dot add this temp dot left, and so I'm not checking this not null, or we can put that condition, right? Okay, let me put this. If q dot sorry, temp dot left is not equals to null, null, then only I should do this, right?
Yeah. Yes.
Q dot add temp dot left, if temp dot right is not equals to null, then I should put q dot add temp dot right, and then I should, after this loop, I should add println system dot out dot println, right? So this will jump to the new line. So that is the code. But here you can see we are running a loop inside loop, right?
Yeah, that's correct.
But eventually we are taking same number of operations. But like you are saying that we are using two loops, and apart from this, everything is same, right? We have this thing same, right?
Yeah.
Everything is same, but here we are using two loops.
That's
okay.
correct.
So both the program are like good, but here we are using extra loop for finding this length, right?
That's correct. Yes.
So you can go with anyone. Okay.
Yeah. That is good.
Now let me let's come back to the whiteboard because we don't have enough time. So let's, okay, most of you had dropped. Okay, so let's solve our graph problem. This was the tree problem. It was based on the DFS, but let's solve one problem. Okay. So let's open the same whiteboard. Okay, are you able to see the whiteboard?
Yeah.
Okay, great. So here, let's say we have this graph. Sorry. We have this graph like this, and we have directional graph. Like this, okay? And we have this. Now, this is the source and this is the target. I just want to know all the possible path from source to this target.
Okay.
Can you tell me what should be the algorithm and how we are going to solve this? So this is the graph. So you can directly think whenever you are having a graph. So you can think about DFS and BFS first. Okay, so that is the simple trick. You cannot solve all the problems through DFS and BFS, but eventually, because you have the graph, so you have to traverse all the nodes. So either you can go with the DFS and BFS in the starting stage, and then you can combine other algorithms. Okay, so just tell me, what do you think? This should be a through DFS or BFS?
Just thinking. So,
okay, so, let me give you a hint. Let me give you. I need a path, a full path, like this one, and this one, and this one. We have total 3 paths.
So I think it can be done with both the BFS and DFS, right?
Okay, okay, no, okay. So as we need a whole path, right? Whole path.
Yeah.
Just think about this. We need a whole path, and this path can be generated through DFS.
Yes.
Okay, so you should go with DFS. Okay, if you are going with BFS, so what should be the problem? Here, you know that we can go here and from here. So you will not get all the path. You can reach from source to destination, but you will not get all the path.
Yeah, that's
getting
right. Yeah.
Getting or not? Like
yes.
Like after this, like you traverse from here, you can go here. Then you don't know that for coming like coming here, how many paths do you have? Like you can either come through here or come through here. So if you just want to check whether you can go from source to destination, then you can either go with DFS and BFS. But when you need a path, so you can simply draw these lines. So it will simply show that this is the process of DFS, right?
So if we want to have all the paths, like breadth first search is the right approach, right?
Yeah. Like when you see the graph, just try to draw these lines. So here we know that I explained through DFS that when we are doing the DFS, we got line like this, right?
Yeah,
so
we only one path, but we don't get all the paths.
Yeah. So if we want whether we can reach here, don't care about the path, we can go with DFS or BFS. But when we so BFS would be great because we will get the shortest path, right? So when we are checking with the shortest path, then also we should go with the this BFS. But when we need all the path, then we should go with DFS, right? So what you can do, you can solve this problem with the shortest path. So you can apply DFS, and you can find all the possible paths. So you can go with DFS, and you can solve the problem. And if you have any doubt, then we can discuss in the other sessions, right? And Suresh and Sam, yeah. Okay. So, yeah. Are you saying something?
Why DFS is good here, Shalikam, actually? So I was kind of
okay. So so you are talking about this all path, right?
Yeah. No. For all possible paths, you said depth first search is more suitable, right?
Yeah. Okay. So you are talking about this shortest path. Why this BFS is good, right?
Yeah.
Okay. Just tell me. We have this. Just focus about the undirected graph. Okay. Undirected means we can go anywhere. Here we have directions so that you can easily understand. Okay.
Got it.
Okay. Sorry. This is the source and this is the destination. Sorry. This is the destination. So DFS will return you this path and this path, right? We have on 2 paths. So we can, if we are choosing this, so we can get this path, and then we can get this path, right?
Yes.
But when we are choosing this BFS, so we are simultaneously going here and here. So we will reach directly from here. We will say that this is the shortest path. Getting or not? Let me show you one more example for this. Okay, I am at the source and this is the destination. So if you are going with the DFS, you will get these paths, right? So it may be possible that you will first choose this one and you can get this directly. But more possibility are like you can choose this one, or let's say if we have one more direction like this, and this. So it may be possibility that there are 30% possibilities, right? 30 and 30 or 33, right?
Yeah.
So if you are choosing this one, so you will get this path eventually. right? Or this path, or this path, or this path, any path, right? We have n number of paths. The shortest path is this. Are you getting me?
Yes,
So
understand.
if you are going with BFS, so we are choosing all the possibilities for the single level. So basically, we can read to we can draw this tree like in a level, and we can directly get this.
Understand.
Okay.
Got it. Yeah,
So I think now you are clear with BFS and DFS, right?
Yes, I understand. Thank you.
Okay, great. So let's